Welcome! In this video series, we'll walk through how ApertureDB workflows simplify end-to-end data operations for multimodal AI applications. Today, we're diving into a key addition to our existing workflow that supports the extraction of embeddings from PDF documents. This lets you find text sections within your PDFs that are semantically similar to a search query, perfect for powering RAG agents that answer questions using your own document repository. Let's start by going to the ApertureDB Cloud interface. For this demonstration, we're going to start off by importing our PDFs from a Google Cloud Storage bucket. We have one prepared that contains several plays by William Shakespeare. We make sure that we're targeting the correct instance, supply the bucket name and Google Service Account credentials, and check that the option to import PDFs is enabled. Finally, we can hit Submit and wait for our job to run. While we're waiting for that to run, here's a view of the bucket we're importing from. You can see that we selected 8 of our favorite plays. Now that the PDFs are ingested, let's confirm they're in the system. We open the Web UI on the Instances page. Here we can see that our instance has 8 blobs, one for each of the plays we uploaded to our bucket. If we go to the Custom Query interface, we can write a simple query to bring back all the properties of these blobs. Now we get to the part where we run the workflow to generate embeddings for these PDFs. Again, select the workflow, check we're using the correct instance, select the model, and ensure that we've chosen to extract embeddings for PDF documents. While that's running, let's talk about what it's doing. First, it searches the ApertureDB instance, looking for blobs that contain PDFs. Second, for each PDF, it goes through every page and extracts the text. Third, for each text block, it breaks it down into short segments, with a small overlap between them. Fourth, for each text segment, we use the model to generate an embedding vector. Fifth, each embedding vector is stored in the ApertureDB instance as a descriptor. We make sure to link it to the original blob. Finally, we mark the blob so that we know not to process it again. If we go back to the Web UI and refresh, we can see that we now have many descriptors in the system. Each PDF page is split into short segments. We can also run a custom query to show all properties of our descriptors. You can see that each one contains the associated text string, the title of the PDF document, the page number in that document, and the segment number within the document. For the last part of this demo, we'll be running a third workflow, our Jupyter Lab server. While we're waiting for that service to start, we'll go back to our instance and generate an API key that we can use to access it. Now we switch to the Jupyter Lab server and open the Clip notebook. We paste the connection Python in to allow the notebook to access the ApertureDB instance. We then enter the prompt string Hamlet for a text search and see sections of the text that mention that concept. That's a wrap! Your PDFs are now smart, searchable, and RAG-ready with ApertureDB workflows. Try it out at aperturedata.io or scan the QR code to get started.